Hi everyone, this is Miss Berry, and today we're going to talk about subtraction of whole numbers. Alright, so in the second grade Common Core Standards, it states the students at this level should be able to add and subtract using within 100 using what they know about place value, properties of operations. That's talking about the associative, commutative, and identity properties, and the relationship between addition and subtraction. And they should also be able to add and subtract within 1,000 using concrete models or drawings, and also learn using what they know about properties of our operations of addition and subtraction. And they should be able to mentally add 10 or 100 to a 3-digit number, and then mentally subtract 10 or 100 from a 3-digit number. Alright, so the 4 subtraction models that we're going to talk about today are the takeaway model, the number line or measurement model, the missing addend model, and the comparison model. These are not the only models of subtraction. I'm sure you could do research and find additional models, but your book picks these 4 models because they give a kind of comprehensive, or they give different approaches for different types of problems. So this is kind of a comprehensive look at the models, and you know, you could use these 4 models to teach subtraction and not have to use anything else. Alright, so the first model is the takeaway model. This is the most simple model. It teaches that taking away some objects from a set will result in fewer objects in the set. Alright, so this is the most commonly taught model of subtraction. And we'll look at an example. Alright, so let's say that Anna has 8 apples. If she gives 3 apples to Naya, how many apples does Anna have left? Alright, so we might draw 2 little circles, one for Anna, one for Naya, and then we'll go ahead and start and give Anna her 8 apples. And then we know that Anna is going to give 3 of her apples to Naya, so we're going to move those over to Naya. And then our question is asking us how many apples does Anna have left, so now students can easily look at Anna's set and count up how many apples she has left. So she started with 8, she gave 3 away, it resulted in her having fewer apples. Alright, so Anna now has 5 apples left. Alright, so the second model of subtraction that we're going to look at is the number line or the measurement model. Subtraction on a number line can be helpful for students to be able to visually perform the subtraction operation on small numbers, and this model teaches that subtraction can be modeled as a backward jump on the number line. Alright, so again, this number line model is good to help students visualize what's happening whenever we perform the subtraction operation, and it's noted in your textbook that this is particularly useful for small numbers, so not as useful when you are subtracting large numbers. And we as the teacher must emphasize that we're making one jump for every count. Alright, so this is how your book presents this. They say if you're trying to model the subtraction problem 5 minus 3. Alright, so they go ahead and they draw out this arrow. Let me use my pointer here, or I'll highlight this. So they go ahead and they're drawing out this arrow for 5 units on the number line. And then you can see up here, they go the opposite direction. So they're counting backwards 3 units on the number line. So this is visually representing taking 5 units and then subtracting 3. Right, and then you look at the spot on the number line where you're left at. This is not my favorite way to draw this, so I did create my own picture to show you how I think maybe a little bit more approachable for students. Alright, so let's say that we have this problem. James has 6 feet of ribbon. If he gives 2 feet of ribbon to Keely, how many feet of ribbon does James have left? Alright, so James has 6 feet of ribbon. Alright, so we start by drawing our number line, and we're going to indicate that James has 6 feet of ribbon. So I'm making my little mark there. on 6 feet, it actually may be better if you draw the whole thing just to indicate that, it starts at 0, goes all the way to 6. All right, he's going to give 2 feet of ribbon to Keely, so we're jumping once and twice. All right, so he's given 2 feet of ribbon, so we jumped 2 times on the number line. And that tells us, if we look at the spot where we're now located at on the number line, James has 4 feet of ribbon left. All right, so I kind of like this drawing with the jumps a little bit better than how your book presents it with just a backward arrow, but either way is fine. All right, so the third subtraction model that we're going to look at today is called the missing addend model. I wanted to point out that this missing addend model of subtraction is part of the first grade Common Core standard. So this is taught even earlier than what we had originally talked about. So this is taught in the first grade. This model of addition, or excuse me, this model of subtraction is useful because it relates addition and subtraction. And it also, if you look at the Common Core standard, it goes on to talk about how these types of problems are good for students to have exposure to early because they help students be able to solve for X. That's kind of the approach here. All right, so the missing addend model teaches that subtraction can be modeled as an addition sentence with a missing addend. All right, so if you remember an addend, that's just a piece of our, so if you had something like 2 plus 4, 2 and 4 are called our addends. All right, so you're taking a subtraction problem and you're just restructuring it as an addition sentence with a missing addend. So for the missing addend model, you might have something like this problem. Maybe you're trying to do 8 minus 3. Oh, and I did want to tell you just a couple of vocabulary words. Whenever you are doing subtraction, this number here, the first number, is called the minuend, M-I-N-U-E-N-D. That's called the minuend, and whatever number you are subtracting is called the subtrahend. So I think I refer back to those words later, so just a heads up. The number that you are starting with is called your minuend. The number that you are subtracting is called the subtrahend. Alright, so say that you have a problem like 8 minus 3. Alright, so the missing addend model of subtraction relates addition and subtraction and emphasizes the connection between those two. Alright, so you might rephrase this as 3 plus what gives us 8. So we're missing that addend. And so instead of thinking about it as subtracting or taking away, you're thinking of it as this is a addition problem and we are just trying to figure out what that missing addend is. Alright, so you might use something like a 10 frame to answer this question. So if you have your 10 frame and then you go ahead and fill in, we know that there are 3. That's one of our addends, and we know that we want to end with 8. So you will keep putting in your little bingo circles, that's what I like to think of them as, until you get to 8 on the 10 frame. Right, so continue adding those until we get to 8. There we are. And then that'll tell you what your missing addend is. So you just count up the blue bingo circle. So that's 1, 2. Let me see if I can get my pointer work. Oh. So if we count these up, 1, 2, 3, 4, 5. So that tells us that our missing addend was 5. And as a result, we know the answer to our subtraction problem, 8 minus 3, is 5. All right, so that's the missing addend model of subtraction. Next, we have the comparison model. This model teaches that subtraction can be modeled as a comparison between two different numbers. Your book notes that this model is harder to visualize because you're not physically taking away objects and counting the remaining objects. You're comparing two different sets of objects. And it also notes, your textbook notes that in order for this model to be effective, your students probably need to have seen subtraction before. So this isn't like what you would want to teach to students first when they're first learning how to subtract. All right, but the comparison model teaches that subtraction can be modeled as a comparison between two different numbers. All right, so let's look at an example. It says, suppose that Juan has 7 Legos and Susan has 3 Legos. How many more Legos does Juan have than Susan? All right, so we'll start off by representing Juan's 7 Legos. All right, and then we're going to bring in Susan's 3 Legos, and we're going to compare those. All right, so we're kind of matching up, and we're saying, okay, here Juan's first Lego matches with Susan's first Lego. Juan's second Lego matches with Susan's second Lego. Juan's third Lego matches with Susan's third Lego. And then from there, we are missing, we have nothing else to match it with. So that tells us that we have a difference of 4 Legos. So Juan has 4 more Legos than Susan. All right, so now a fact family, you have a couple of questions on your homework related to fact families. And a fact family is just a group of related facts using the same numbers. And so I want to show you this. This is called a fact triangle. You're going to be asked to, I want to say it's multiple choice, and you have to select all of the related facts for a particular fact family. So for the fact family 7, 5, and 12, we have the following fact family. 7 plus 5 is 12. 5 plus 7 is 12. So just that's the commutative property, just switching that order. And then we also have that 12 minus 5 is 7. And then similarly, 12 minus 7 is 5. So all of the ways that you can use addition and subtraction to relate those 3 numbers. All right, so that is what a fact family is. And fact families, to me, are helpful for that missing addend model. Right, so you can kind of see how you're relating, like a subtraction problem like this can be directly related to these addition problems. All right, so it kind of reminds me of that missing addend model. So if you were using that missing addend model, you might want to start by talking about fact families. All right, so one thing that I need to tell you about whole numbers and subtraction is that the whole numbers are not closed under subtraction. Now, this is kind of a fancy mathematical term, but in the most basic explanation for this is that this means that whenever you subtract 2 whole numbers, the result is not necessarily a whole number. All right, now that sounds kind of complicated, but let me just show you an example. So it says, when 2 whole numbers are subtracted, the result is not necessarily a whole number. Sometimes it is. You might have something like 5 minus 3 is 2. 5 and 3 are whole numbers, so is 2. But if you switch that around, 3 minus 5, what's 3 minus 5? That would be negative 2. That is not a whole number. Negative 2 is not a whole number. Remember, whole numbers are positive integers and 0. Oh, I was trying to write number there, but I wrote value. All right, so that is not a whole number. All right, so what that means is that you just want to be careful whenever you're creating these problems for your students. So make sure that you're not going to end up giving them something that's a negative number when you haven't learned about negative numbers yet. All right, so now let's talk about the subtraction algorithms. All right, so we have 4 subtraction algorithms that we're going to look at. The first is using base 10 blocks to develop our standard algorithm. Then we'll look at equal additions algorithm, then the counting up algorithm, and then trades first algorithm. All right, so using base 10 blocks to develop our standard algorithm, I really like this method. We're going to be looking at this problem 58 minus 27. All right, so 58 minus 27. If we want to take those two values, our minuend 58 and our subtrahend 27, and represent those with base 10 blocks, we can do that. All right, so 58, I've got 5 10s, 8 1s. All right, then for 27, I'm going to have 2 10s and 7 1s. So I'm going to take away, and the way that I saw this being done in your textbook is that they put a little X over the number that they're taking away. All right, so we're trying to take away 27, so take away 2 10s and take away 7 1s. 3, 4, 5, 6, 7. All right, so we took away 7 1s. And then you just look at what's left. All right, so count up what's left. We have 3 10s and we have 1 1. All right, so that's 31. All right, so that is just motivating our standard algorithm, which would look like this. 58 minus 27. We would say 8 minus 7 is 1. So subtracting the 1s, and then 5 minus 2 is 3. All right, so using base 10 blocks is a great way to motivate our standard algorithm. The next subtraction algorithm we're going to talk about is called the equal additions method. This is sometimes called the borrow and repay method. It is widely used in Australia and in Latin America. It's based on the fact that the difference between two numbers does not change if we add the same amount to both numbers. All right, so let me just highlight a couple of things here. So this algorithm is based on the fact that the difference referring to subtraction here, the difference between two numbers does not change if we add the same amount to both numbers. All right, so basically, if you have something like 47 minus 18. All right, so the subtraction problem is easier if the subtrahend, that's the number that you're subtracting, ends in a 0. All right, so that's kind of your goal with this method, is to make the subtrahend end in a 0. All right, so in this method, or in this particular problem, you could take that subtrahend and add 2. So add 2, make it 20. Whatever we do to the subtrahend, we're going to do the same thing to the minuend, because this algorithm is based on the fact that the difference between two numbers does not change if we add the same amount to both numbers. All right, so we're going to do the same thing to our minuend. All right, we're going to add 2 to it. And now this problem is much easier to subtract. 49 minus 20, we can easily subtract that. Whereas with this method, if we were just using our standard algorithm, we would have to go over here and say, okay, we're going to have to borrow from 4 to make that 17. All right, so the equal additions method, it focuses on taking that subtrahend and making it end in a 0, if that makes sense. All right, so let's look at an example. Let's say we have 58 minus 27. Now I'm using this same example from before, but this method is particularly useful for the case like I just showed you, where you're going to have to borrow from the neighbor. All right, but we're going to use this same problem so that we're just kind of consistent, and I'm showing you all the different methods with the same subtraction problem. All right, so again, with the equal additions algorithm, you're trying to make that subtrahend end in a zero. So you're going to take 27, add 3 to it, and that's going to make it 30. Whatever we do to the subtrahend, we need to do to the minuend. So we're going to add 3 to it as well. All right, so that makes it 61. All right, now we can subtract those. 61 minus 30, that's much easier to subtract. 1 minus 0 is 0. 6 minus 3 is 3. All right, so that's 31. The next algorithm we're going to look at, the third algorithm, is called the counting up algorithm. This algorithm can be best described as like a making change method. So imagine if you were a cashier and you needed to, maybe someone's total is $12.44, and they gave you a 20. Then you might use the counting up algorithm to make change for them. So let's look at the description. It says, this algorithm uses the idea of a missing addend, the missing addend model for subtraction. And I went ahead and put the steps in because I know a lot of you may not be familiar with making change, since, now if you've ever worked at a cashier type job, it'll just tell you what the change is for the customer, so you don't have to count that up yourself. All right, but I wanted to make sure that you knew step by step how to do this. So the steps for the counting up algorithm are here. Step 1 is to count up from the smaller number to the next 10. All right, so you're going to start with your smaller number, count up to the next 10. Then you're going to remember this count. All right, so I'm going to make up a little problem here. Let's say, I don't know, 29 minus 17. All right, so you're going to count up from the smaller number to the next 10. All right, so our smaller number is 17. Counting up to the next 10, we would go up 1, 2, 3 to go to 20. So we would go up 3 to get to the next 10. All right, then you're going to count from that 10. It says count up from this 10 to the larger number. All right, so we're at 20 right now. We would need to go up 9 more to get to the larger number of 29. Add this count to the first count to find the total difference. So 3 plus 9 is 12. All right, so it's just kind of taking a subtraction problem and using that idea of a missing addend. All right. So it's basically asking, if I took 17, what would I need to add to it to get 29? All right, so it sounds complicated, but I think when you see it in action, you're going to see it. It's actually pretty simple. All right, so let's take our problem that we've been working with, 58 minus 27. All right, so just to recall, the steps are to count it from the smaller number to the next 10. We're going to remember that count. All right, then we're going to count up from that 10 to the larger number, and then add this count to the first count to find the total difference. All right, so we're starting with the smaller number of 27. We're going to figure out what do we need to add to it. So we're going to count up to the next 10. So we would add 1 to 28, 29, 30. All right, so we're going to remember that count of 3. We had to go up 3. And then it says count up from this 10 to the larger number. So we're going to count up from 30 to 58. So 30 plus 28 would give you 58. All right, so 30 plus 10 plus 10 plus 8. All right, so again, just recalling from those Common Core standards that students were expected to be able to mentally add 10 in their head. All right, so we would need to add 28 to get to that larger number. All right, so that was step 2. And then step 3 says add this count to the first count to find the total difference. All right, so add 28 to our first count, 1, 2, 3. 28 plus 1 is 29, plus another one is 30, plus another one is 31. I feel like I made that sound a little more complicated than it was, but hopefully the visual helped you see that it was pretty simple. Alright, and our last algorithm, our last subtraction algorithm is called the trades first algorithm. When I first looked at this algorithm, I thought it looked really complicated, but whenever you start using it, it's actually pretty interesting. Alright, so the trades first algorithm is similar to the standard algorithm, except that all regrouping is done before any subtraction is carried out. Alright, so you want to start by looking at the problem and determining, is there going to be any regrouping that I have to do, and if there is, I'm going to do that first. Alright, so this method is specifically good for problems where you need to regroup or borrow from your neighbor. So it's specifically good for regroup or problems where you have to borrow from your neighbor. Alright, so since this method is best illustrated with a borrowing or regrouping problem, I did change the problem slightly. Alright, so I changed it to 52 minus 27, so instead of 58 minus 27. Alright, so you're going to start by writing your menu in. That's our original number that we started with, so 52. So we're going to start by writing 52. Right, then we are going to determine if we need to regroup. We are going to need to regroup because we cannot take 7 away from 2. So we're going to start by regrouping here. We're going to take one of the 10s and we're going to change that into 10 ones. Right, so we're going to trade one of our 10s for 10 ones. Alright, so instead of having 5 10s, we're now going to have 4 10s, and that 1 10 got converted into 10 ones, so we went from 2 ones to 12 ones. Alright, once you have regrouped, then you're going to write down your subtrahend. Alright, so write down the subtrahend in the correct columns. So we're going to subtract 37, so minus 37, and now you can see our, we don't need to do any regrouping now. We've already taken care of that, and we can go ahead and subtract. So we're going to subtract, sorry, my numbers are wrong here. Subtract 3 from 4, that should say. Subtract 3 from 4 and 7 from 12. Right, so if you subtract 3 from 4 and 7 from 12, that gives you 15, which is our final answer. Alright, so that's the trades first algorithm. And this might be best illustrated if you're working with base 10 blocks, so this might not be something that you want to do you know, when students are first learning how to subtract, but it is a good way to get students thinking about how you can switch around place value, or switch around some of our units and trade them in for different units. Alright, so the last thing that we need to talk about is mental mental computation with subtraction. Just like we covered with addition, there are several different algorithms that you can use for mental computation with subtraction of whole numbers. And your book emphasizes that mental computation strategies help students produce the answers without having to physically write anything down or physically manipulate anything like any base 10 blocks or anything like that. And we also want to emphasize that if we're doing any kind of approximating or estimating, you know, that that is you know that approximations are good, but only when they're used in the appropriate environment. All right, so our first method is called breaking up and bridging. You may remember that from when we talked about addition of whole numbers. All right, so with breaking up and bridging, you're going to take your minuend and you're going to subtract off the tens. Right, so 67 minus 30. All right, so you're going to start by taking 67 and subtract 30. That gives you 37. It's always easier to subtract a number that ends in 0, so we start off with that. And then we're going to say, okay, well, we subtracted 30. We need to subtract 6 more. So you're going to take your 37, subtract 6, and there's our final answer of 31. The next method is called trading off. Trading off is where you try to make your minuend end in 0, right? So we're going to take our minuend, add 4 to it to make it 40. Then we're going to trade off and take our we're going to take our subtrahend, add 4 to it to make it 40. Then we take our minuend, we're going to trade off and subtract 4. That gives you 63. Right, then we can easily subtract those two. 63 minus 40 is 23. Right, so with trading off, with addition, it didn't really matter which addend you made end in 0, but with subtraction, it is important. You always want to make the subtrahend end in 0. All right, and then our last method of mental computation is drop the zeros. This is a great method for if you have a really big number. Like for example, here we have 8,700 or 8,700 minus 500. And this method says that you can match up your zeros. So, okay, this 0 matches with this 0, so matching up the place value, that's in the tens place. This 0 matches with this 0, that's in the ones place, and you can drop those zeros. So if you have matching zeros, you can drop them. But we do want to remember, keep them in mind because that's going to be part of our final answer. But then we can just do 87 minus 5 is 82. We know that that was in the thousands place. So we add on those 2 zeros that we had originally dropped. All right, so we drop 2 zeros. We take our subtraction, 87 minus 5, then we add those 2 zeros back. That's your final answer. So that is everything that I have for subtraction of whole numbers. If you have any questions over this method or over the homework, make sure that you email me. Otherwise, I'll see you guys soon. Have a good day.